Alright, so here we have a single wire ACB of length 2 meter, passes through a ring at point C. So here is the wire. It's going to be hooked up at point A. It's going to be looped around point C. There's a little hook there, and then it's going to be attached to point B. And it says here the object is moving at a constant speed v, and it says knowing that theta 1 is 60 degrees, theta 2 is 30 degrees, and that the tension in both the strings are the same, or the portions of the strings are the same. It's just determine the speed v. So once again, here's one wire and its length of 2 meters. It's going to be attached from A, it's going to be wrapped around C, and then it's going to go up to point B. Theta 2 is given as 30 degrees, and then theta 1 down here is given as 60 degrees. All right. So let's go ahead and find V. To find V, I'm going to draw my free body diagram. I'm just going to keep the subscripts the same. This is theta 1, so I'm just going to call this T1 for the sake of consistency with subscript. And then T1 in this case is pointing to the left and up. So my T1X is going to point left, and then my T1Y is going to point up. And then likewise with T2, I'm just going to keep the orange arrow here. I'm just going to call that T2 because it's theta 2. T2 is also pointing up and left, so therefore T2Y is pointing up. And then T2X is going to point to the left as well. So here, it asks for a speed. This is a conical system with, once again, just one rope though, but the rope is looped around point C, and it has the same tension in both sections of the string. So let's go ahead and set up our f of g here. Why? Because you need f of g in order to figure this stuff out. You're left with a system of equations here in the x and y directions. Okay, so this is a centripetal problem, so I'm just going to go ahead and set up my statement. F of c here is equal to T1x plus T2x. T1x is pointing leftward towards the center of the circle, towards this rod here, and then T2x is pointing leftward as well. So you have two horizontal components pointing towards the center of the circle. Here I'm just looking at the magnitude. So therefore, f of c is just mv squared over r. I don't know what r is. And then T1x can be broken down to T1 sine of 60. The angle, both the angles here is given touching the vertical axis, so be careful with that. T1 is the opposite leg, so therefore opposite is sine. And likewise with T2x, T2x is the opposite leg of theta 2. That's also sine. So here we have T1x is T1 sine of 60. T2x is T2 sine of 30. And then I can just fact out this T here. It says both portions of the wire have the same tension. So instead of T1 and T2, we'll just call that T. Both terms have a T, so factor that out. So here you're left with the statement. Here I don't know R, I don't know T, but I'll just go ahead and solve for T real quick by setting up the information in the y direction. As I stated earlier, you're going to be left with the systems of equations with two or multiple unknowns here. Here in the y direction, we have T1y pointing up. We have T2y pointing up as well, and that must equal to the vector pointing down, which is the weight of the object here on this f of g. This is not drawn to scale, but technically f of g should be longer. I'm just running out of space on this diagram here because this diagram I made it large, so it's easier to draw the triangles. Okay, but to be technical, f of g should be equal to the magnitude of T1y and T2y. So if you want, draw that longer if you would like to. Other than that, I'm just going to make the statement. The two components pointing up must equal to the vector pointing down, which is f of g. Here, just using geometry once again, T1y and T2y's are both touching the angle on the vertical axis here, and these will be your cosine. Okay. Once again, just be careful when your theta is given touching the vertical axis. Your sine and cosine flip. So in this case, y would be cosine. So here T1y is just T1 cosine, T2y is T2 cosine, and cosine of 60 and cosine of 30. All right, once again, we can factor out T because T1 and T2 are equal because it said so. And then from here, I can just solve for T. Why? Because I need to solve for T over here. And then other than that, I'm just going to divide both sides by the whole product, the whole sum here of cosine of 60 and cosine of 30. So I'm going to move that whole parentheses to the bottom right, so it'll be mg over cosine of 60 plus cosine of 30. So over here I'm just going to substitute in for t. So whatever t is, I can substitute in mg over cosine 60 plus cosine 30, and then I want to carry down sine of 60 and then sine of 30 down. However, if you know your geometry, this sum here, cosine of 60 plus cosine of 30, will actually cancel out with sine of 60 and sine of 30. because the opposite of sine of 60 is cosine of 30, and then likewise sine of 30 is cosine of 60. So if you actually plug this in your calculator if you want to, it'll cancel out. I cancel mass out too because both terms, both sides have a mass. Okay, so as you can see here, it is independent of the mass that's being swung here around a conical system. All right, other than that, I'm just going to go ahead and simplify this. V squared of r, and then g is just 9.8. I'm just looking at the magnitude here because it asks for speed. Keep in mind, as the conicals rotate in a horizontal circle, its velocity changes anyways because the direction continually changes. But the speed can stay constant, okay, because speed is just a scalar. All right, other than that, to get v squared by itself, I'm just going to multiply both sides by r. So here we have v squared is equal to 9.8 times r. I don't know what r is, so if you saw the previous video, I will go ahead and show you how to find r using geometry as well. All right, so let's go ahead and find r. So here is length 1. I'll just call that length 1 once again because subscript 1 for theta 1. Here's L1x, and then here's L1y. You notice all I did was I made it into a right triangle. And then likewise with the top portion of the string here, L2. And then this is L2x, and then this is L2y. Okay. What I do know that is true is that I do know L1x must equal to well, 1x equals to L2x, right? Because both of these lengths are the same. All right. Other than that, I can go ahead and substitute it out. L1x is L1 sine of 60, because if you look at this blue hypotenuse for L1, L1x is the opposite leg relative to this angle theta 1 that's given to us, and opposite is sine. And likewise with L2, L2 is this orange hypotenuse, theta 2 is given touching the vertical axis, and the opposite of that would be L2x. So while both these are L1x and L2x, they are sine because the angle is given touching the vertical axis. All right, here I'm just going to isolate for L1 just because it's already on the left side. So I'm going to divide both sides by sine of 60. If you like, you can simplify this on at this point, but I'll just keep going. I'll just keep it as is. Okay. What I do know is, though, I do know the statement, right? The problem says that the length of the wire is 2 meters. So watch my cursor. You're going to hook up to A, and you're going to pull that 2 meter wire down all the way to C, and then you're going to wrap around it, and you're going to hook it up to point B right there. So this whole entire leg right here and that must equal to 2 meters because it said so. So I just made a true statement. I made L1 plus L2 is equal to 2 meters. What I do know is that I do know what L1 is, right? So here, I don't know what L1, L2 is, but I can get rid of L1 because I already found L1 over here. So L1 here is just simply L2 sine of 30 divided by sine of 60, which I made the substitution there. So as you can see here in this statement now, we only have one unknown, which is L2. So here, if you want, punch in your calculator, you can just take my word for it. Sine of 30 divided by sine of 60 is 0.577 times L2 because that's your unknown as well. So here we have 0.577 L2 plus L2. So this is just 1, and that equals 2 meters. So 0.577 plus 1 is 1.577 L2. And then to get L2 by itself, we divide both sides by 1.577. And then L2 is going to give us a length of 1.27. Okay, so of the 2 meters, L2 here is going to take up about 1.27 meters. So the leftover must be L1. So there's one way to look at it. All right, other than that, I'm just going to go ahead and crack it out. Here with R, R can be L1x or L2x. Since I already have L2x, I would just use L2. I mean, since I already have L2 here, I would just go ahead and use L2x. And as stated up here earlier, watch my cursor where I'm circling back and forth. L2x is L2 sine 30, right? So I can say R is L2x, but L2x is L2 sine of 30. But I already found L2, which is 1.27. So I'm going to substitute an L2 for 1.27. I'm going to times that by sine of 30, which is a half, which is now 0.635. So that's my R, right? Now that I have my R, I can just plug it back into the statement in the previous slide. So V squared, we said earlier, was 0.98 times R. I found R, so now I can just plug and chug. I'm just going to carry 0.98 down for R. I'm just going to plug in 0.635 because I just found it. This is V squared. So 9.8 times 0.635 is about 6.223. But then to get V, I need to square root both sides. And then so the square root of 6.223 is 2.49. And that is your answer. Okay. And then this is consistent with what I found via World Wide Web. And whatever source this is, it's just the answer is 2.49. So hopefully you're not tripping out. All right, stay nerdy, don't be whack.